Hey everyone, welcome back to my channel. So, have you ever wondered that how Netflix is recommending you the next show or how the images are stored in the AI model? So, the secret lies in the matrices. So, when you are writing a machine learning algorithm, you are not just coding, but you are thinking in terms of matrices. So, knowing the different kind of matrices will not only help you to visualize but to structure your logic. It will help you to how to structure your logic. So today we are going to learn about the different kind of matrices. So I have written out the major important type different kind of matrices here. So there are total 11 kind of matrices, so we are going to study that. So first we will begin with the row matrix, or we can call it as a row vector. So I can represent the row matrix as like A equal to 1, 2, 3, 4. So this is called the row matrix or row vector. So how this is derived? So I can write it as X, a matrix X, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 3 cross 3 matrix. So for example, if I choose the first row, then I can consider it as a row matrix or a row vector. So the shape of this row matrix is 1 cross 4. So here the total number of rows are only one. So there is only one row, but it can have multiple columns. So currently in that case, there are 4 columns. Now coming to the column matrix, so I can write the column matrix as 1, 2, 3, 4, and it will have 4 rows but single column. So you can say that it is a vice versa of row matrix. So in the column matrix, the number of columns is always limited to only one, but it can have a multiple number of rows. And the shape of this matrix is 4 cross 1. And I can also call it as a column vector or the column matrix. Now coming to the square matrix. So in the square matrix, generally the number of columns and the rows are same. So I can write this as a 1, 2, 3, 4. So this is a 2 cross 2 square matrix. Here the number of rows are 2 and the number of columns are also 2. Similarly, I can write a different matrix. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 cross 3 matrix. So in this case, the number of rows and the number of columns are same. So there are total 3 rows and 3 columns.
Now coming to the diagonal matrix. So in the diagonal matrix, the elements which are not diagonal, okay, are 0, and the elements which are in principal diagonal are non-zero. So let me show you. Here is the matrix A having the elements like 2, 0, 0, 0, 3, 0, and 0, 0, minus 1. So in this case, this is a 3 cross 3 diagonal matrix. So here on these diagonal axis, you can see this. The elements are non-zero elements, and rest of the elements which are non-diagonal, which are not diagonal, are 0 in case of diagonal matrix. So there is one condition here for the diagonal matrix, that is I equal to j not equal to 0. So in case of diagonal matrix, the element at I position, that is in the row, equal to column. Okay, so when this condition satisfy I equal to j, so for example in this case the first element, that is the row equal to 1, column equal to 1, that is I and j are both equal. In this case, in the second row, the element is at second row, position is located in second row and second column. Okay, in that case I equal to j, and which is not equal to 0, that is a non-zero element. So I can say that this matrix is called the diagonal matrix. Now coming to the scalar matrix. So a scalar matrix is a diagonal matrix, but the elements, okay, the diagonal elements are always the scalar value. So I can write it like this: a equal to k 0 0 0 k 0 0 0 k. So this value, okay, this items elements on the diagonal axis are always same in the scalar matrix, and this is a 3 cross 3 matrix. Now coming to the identity matrix. So identity matrix is also a diagonal matrix, but the diagonal elements are always one, and it is denoted by I. 0 1 1 0 0 1. So this is 3 cross 3 identity matrix, and the diagonal elements, you can see that they are always 1. Similarly, I can write it another identity matrix, that is 2 cross 2, that is 1 0 0 1. Now coming to the zero matrix. So as per the name, okay, you can understand that the zero matrix always contains the zero elements. The value in the elements will be the zero, okay, will have the zero value in the matrix. A equal to this is 3 cross 3 zero matrix, and B equal to 0 0. This is 2 cross 2 zero matrix.
Then we'll be studying the equal matrix. So in the equal matrix, there will be a two matrix, and in those two matrix, the order will be same, and the corresponding entries will also be the same. So for example, A equal to 1 2 3 4, and B equal to X Y Z W. So in this case, you can see that both are 2 cross 2 matrix, so their order will be always same. The first condition to satisfy the equal matrix is the order of both matrix should be same, and the corresponding entries should also be the same. So for example, x must be equal to 1, then y must be equal to 2, and z must be equal to 3, and w must be equal to 4. So this is the condition for the equal matrix. Then coming to the transpose of the matrix. So in the transpose of the matrix, we will be converting the rows into columns and columns into rows. So I can write it as a matrix A, that is 1 5 2 3 4 1. So this is 3 cross 2 matrix. The shape of this matrix is 3 cross 2. So when I write the transpose of this matrix, that is 1 2 4 5 3 1. So the shape got changed to 2 cross 3. So what we did is we converted the row. Okay, so this first column, okay, this first column you can consider is converted into the row, and similarly this second column is converted into the second row. So this is how we write the transpose of the matrix. Now coming to the symmetric matrix. So in the symmetric matrix, when we do the transpose of the a matrix, then the resulting matrix and the original matrix must be same. Okay, so for example, I can write this as a must be equal to the transpose of A. So for example, the matrix A is equal to 1 2 2 1, and the transpose of the matrix A can be written as 1 2 2 1. So in this case you can say that both the matrix, if you are changing the rows into columns and or column into rows, then the both the matrix will be same. So this is a 2 cross 2 matrix, it is also the 2 cross 2 matrix. So I can say that this matrix is the symmetric matrix. So when you do the transpose of a matrix and the resulting matrix is equal to the original matrix, then we can say that it is a symmetric matrix. Now coming to the skew symmetric matrix. So in the skew symmetric matrix, there is a condition, that is A equal to negative of A transpose. So if these conditions satisfy, then you can say that this matrix is called the skew symmetric matrix. So for example, I can write A equal to 0 3 1, then minus 3 0 minus 4, and minus 1 4 0. So when I do the transpose of this, it will be 0 minus 3 minus 1, then 3 0 4, and 1 minus 4 0. So I can write this transpose of A as, if I take a negative sign out of this matrix, a common, as a common, then I can write it as a 0 3 1 minus 3 0 minus 4, then minus 1 4 0. So this matrix is same as this one, okay, but there is a negative sign common. So I can write it as a equal to minus of A transpose. So this is nothing but a skew symmetric matrix. Now there are certain rules for the transpose of the matrix. So the first rule is, if you take a twice transpose of a matrix, then it will be back to the original matrix. So for example, if I write it as a A transpose of transpose, then which is nothing but a equivalent to A only. Then second is, if I take a transpose of sum of two matrix, that is A plus B, then it is similar to the sum of transpose of two matrix, that is A of transpose plus B of transpose. And the third condition is, if you multiply two matrix and take a transpose of it, then which is nothing but equivalent to A of transpose multiplied by B of transpose. So these are the rules for the transpose of the matrix. So hope you like my video, and if you love this video, then don't forget to subscribe and hit the bell icon so you don't miss the next video in our linear algebra series for the machine learning. So thanks for watching. We'll see you in the next video.